In this video, we are going to talk about exponential function. What is the exponential function? For example, we have fx equals to b to the power x. b is the base. b is our base, which is constant, and x is our exponent, which is independent variable. Independent. Where b should be greater than 0 and b never equals to 1. In that case, we are going to call it exponential function. Let's move on to solving examples. Example 1, we are going to graphing exponential functions. Branch A, we have fx equals to 1.5 to the power x. We have to graph this function. Before graphing this function, let me tell you something. A function of the form of fx equals to a b to the power x. This a is a coefficient. This a is a coefficient. So we have some cases. If a is greater than 0, which is positive, and b greater than 1, and b is greater than 1, we call this function growth function, exponential growth. We call it growth. Our graph will be a growth function. 0 less than b and less than 1. It means b, our base, if it is between 0 and 1, it means the 0 and 1 is not included between them. If it is between them, we call it exponential decay or decay function. This is a note you have to consider about it. So, based on this note, we can immediately know this function is a growth. This function is a growth function. Why? Because we have 1.5, which is greater than 1. Now, let's graph the functions. We are going to give points. For example, we have -2, the easy points, -1, 0, and 1, and 2. We are going to plug these x values within this x. So, for example, if you put -2, it will be f of -2 equals to 1.5 to the power -2 equals to 0.4. If we repeat the same process for -1, we will get 0.7, and for 0 we will get 1, and for 1 we will get 1.5, and for 2 we are going to get 2.3. This is how we find the values of y. Let's put these points on the coordinate plane. -2 with 0.4 is nearly here, and we have -1 with 0.7. The second point, it will be nearly here, and we have 0 and 1, which is here, and we have 1 and 1.5. 1 with 1.5 is here, and we have 2 with 2.3. 2 with 2.3 is nearly here. So the graph of exponential function should go through the points. So it goes like that. So this is exponential growth function. If we want to find the domain and the range by looking at the graph, we know that domain, it depends on x-axis. So the graph goes from the negative infinity to the positive infinity. So our domain is all real numbers. For the range, we know that range, it depends on y-axis. So if you see the graph never cut 0 of y, doesn't never cut 0. So it goes for the positive infinity. So it means y is greater than 0, or we can rewrite it like that: 0 and positive infinity. So this is the domain and range of this function. Let's move to the next example. For the branch B, we have 3 multiplied by 0.8 to the power x. So based on the note that I wrote it for you, this is A, which is positive and greater than 0, and 0.8, which is between 0 and 1. So clearly we can say it's a decay exponential function. So this is decay function. Now we are going to give the points -2 and -1, 0 and 1 to this function. We are going to get the points like this. For -2 we have 4.7, and for -1 we have 3.8, and for 1 we have 2.4, and for 2 we have 1.9. Now we are going to plug these points on the coordinate plane. -2 with 4.7, -2 with 4.7 will be here, nearly here, and -1 with 3.8, -2 with 3.8, nearly here, and 0 with 3, and 1 with 1, and 1 with 2.4, 2.4 nearly here, and 2 with 1.9, 2 with 1.9. So the graph is decay, so it is somehow like this. Sorry for our handwriting. So the graph will be a decay function, as you see. Based on this graph you can find the domain and we can find the range. As we discussed, domain, it goes with the x-axis, which is r, because the graph from the negative infinity goes to positive infinity. And for r is y greater than 0, because we have it goes from positive infinity to nearly 0. So our part graph is 0 for negative infinities. So it will be y greater than 0, or we can rewrite as like this. This is how we graph exponential functions and how we determine whether it's growth or decay. Thank you so much for listening.